And welcome back, students. Let's get into defining exception classes as we trudge through our lessons on exception handling basics. So, getting started. A throw statement, if you recall, pretty much can throw an exception object of any exception class. And we've seen this with the exception E demo. A common thing, though, we can do is define an exception class whose objects can carry the precise kinds of information you want thrown into the catch block. An even more important reason for defining a specialized exception class is so that you can have a different type to identify each possible kind of exceptional situation. So rather than just using a generic exception to catch everything, we can specify it in order to really kind of hone in on what kind of errors are being commonly thrown. Now, every exception class you define must be a derived class of some already defined exception class. So an exception class, therefore, can be derived class of any exception class in the standard Java libraries or of any exception class that you've already successfully defined. So our examples that we're going to look at are going to be derived classes of the class exception. All right, let's look at some constructors here. So when you're defining an exception class, the constructors are the most important members. Now, often there are no other members other than those inherited from that of the base class. So, for example, in our division by zero exception, we have defined an exception class whose only members are no arg constructor and a constructor with one string parameter. So if we just pop over to Eclipse real quick here, and we look, we have our no arg constructor here, public division by zero exception, super division by zero, public division by zero exception, string message, super message. In most cases, these two constructors are all the exception class definition contains. However, the class does inherit all the methods of the class exception, hence the supercalls. In particular, the class division by zero exception inherits the method getMessage, which returns a string message. In the noArg constructor, this string message is set with the following, which is the first line in the noArgument constructor definition, super division by zero. This is a call to the constructor of the base class exception. As we've already noted, when you pass a string to the constructor for the class exception, it sets the value of a string instance variable so that it can later be recovered with a call to getMessage. Now, the method getMessage is an ordinary accessor method of the class exception. The class division by zero exception inherits this string instance variable as well as the accessor method getMessage. So really, it's not changing any way of how we've been doing try, catch, throw. The biggest thing that's changing is that we can specify what we want it to be. So let's look at this with an example. In our division first demo version, we give it a sample program that uses this exception class. So let's just take a look quick here. So here we have our class right here, and you can see in here we have a throw right here, throw new division by zero exception. The exception is thrown with the noArg constructor as follows, which I just pointed out. And this exception is caught in the catch block shown in division first demo version. Catch block, of course, being right here. And you'll notice that this is very similar to what we've seen like before, like exception E, and then we would call it whatever the message is. You'll notice that the formatting of that is almost identical to what we've seen, except instead of this saying exception, it now says division by zero. So it's letting us be specific to let us know which exception we're calling, rather than just the general exception E. Well, now it's division by zero exception. So consider the following line from that catch block. System.println e.getMessage. Let's examine what occurs when we look at some sample inputs. So in here we have sample dialog 1, where we entered in 11 and 5. So I did 11 divided by 5, 2.2, and a program. Here we did 11 and 0. We get division by 0. Try again. 11 and 5, you'll get again the same thing. Because it'll say, be sure the denominator is not 0, so boom, valid, and a program. This one, 11 and 0. Try again. 11 and 0. I cannot do division by 0, aborting program. So let's analyze those example inputs that we just did and see how that is broken down in terms of how the program functions. Now, this line, of course, produces the following output to the screen in sample dialogs 2 or 3, division by 0. The definition of the class division by zero exception has a second constructor with one parameter of type string. This constructor allows you to choose any message you like when you throw an exception. If the throw statement division demo first version had instead used the string argument, throw new division by zero exception, oops, shouldn't divide by zero, then in sample dialogues 2 and 3, the statement system of println e.get message would have produced the following output to the screen. Oops, shouldn't divide by zero. But if you look here, we're using right here a no arg. Right? And so because it's using the no arg, it's coming back and outputting here division by zero. If we wanted to say something else, such as this, we actually just put that in there, and when it does the e.get message call, it's going to go ahead and return that to us. All right, let's kind of just wrap this up real quick here and kind of bring everything we talked about together. You'll notice that in division by zero exception, the try block is the normal part of the program. If all goes routinely, then the only code that will be executed is that, right? And the dialog will be just like the one shown in the sample dialog number 1. In the exceptional case, when someone decides, hey, I'm going to plug 0 for a denominator, the exception is then thrown and is caught in the catch block. The catch block then outputs the message of the exception and calls the method second chance. All right, second chance, of course, being defined right here. The method second chance gives the user a second chance to enter the input correctly and carries out the calculation. If the user tries a second time to divide by 0, the method will end the program. The method second chance is there only for this exceptional case. Because if you look at, we do the valid case right here, never can we access second chance. So it only exists for when you do an incorrect input like that. So therefore, we separated the code for the exceptional case of a division by 0 into a separate method, where it's not going to color the code for the normal case. Yes, technically we could put it up into that one program, but by separating out here into its own method, it keeps it clean from the main method that we would have right here, where our program would function under normal circumstances. All right, and that's going to wrap it up for today, folks. So, until next time.